Hi everyone. Today we are going to do about electric dipole. As we have finished electric field, electric field, about electric charges. Now the next topic is what? Electric dipole. We'll see in this topic completely about electric dipole. What is dipole moment? What is the electric field due to a dipole at an axial point? What is the electric field due to a dipole at an equatorial point? And behavior of a dipole in a uniform electric field we'll see in the next lecture, but these things we'll see, and related numericals on these two topics. Fine. What is dipole? Dipole, if you will see, suppose let's take two charges, 2 point charges, the first thing, and that should be at rest because it is we are learning electrostatic chapter. So if you will see, this is a point charge here, this is 1 point charge here. So we can say both the point charges are opposite in nature. One is positive, one is what? Negative. So both the point charges are what? Opposite in nature. Point charge as well as what? Opposite in nature. The distance between them is what? 2a. The distance between them is what? 2a. So we can say easily we can say net force is what here? Net charge is what here? Plus q minus q. Plus q minus q. Net charge is what? 0. And then net force is what? Force is what? Q into E. Q into E. One is minus QE, one is what? Plus QE. So it is going to be what? 0 again, right? Net force is going to be what? 0. Net charge is also 0. Net force is also 0. So we can say in a dipole, it is a combination of 2 point charges, right? Here, when 2 point charges are separated by a small distance, when 2 point charges are separated by a small distance, and net charge on the dipole is what? 0. Net force is what? 0. That is known as what? Dipole, electric dipole. Let's write that. So what we learned, like if you'll consider two charges, minus q and plus q, and the distance between them is what? QE. If you'll see here, net charge is what here? 0 plus q minus q. Net charge is 0. So we can say net force is also what? 0. Plus QE minus QE, it is what? 0. The main thing which we are supposed to learn here is about what? Dipole moment. Dipole moment is what? Product of either charges and the distance between them. Okay, before that we can say some example like HCl. H is positive, Cl is what? Negative. So we can say here HCl we can say there we can say one charge is what? So we can say one charge is positive, one charge is what? Negative. H plus Cl minus. Example, if you will take H2O, so O H H. So we can say H plus 2 minus, right? This minus this. So by that way we can say this is dipole, this is also dipole, this is also what? Dipole. Now the next topic which we are going to learn here is what? Electric dipole. Electric dipole we learned. Dipole moment. Dipole moment. If you'll see, product of either charges and the distance between them. What is dipole moment? Product of either charges and the distance between them. Product of either charges and the distance between them is known as what? Dipole moment. So we can say minus q charge plus q charge, two-way distance. So we can say and it is a vector quantity. Let's see, first it is denoted by what? P is equal to product of either charges. So q into what? 2a. Any charge you can take. Generally we are taking what? Positive charge. So unit, if you will see guys, unit if you will see, coulomb and then distance, right? So coulomb meter, that we can write. not centimeter, right? It is what? Coulomb meter. After that, what? It is a vector quantity. It by convention we are taking charges from negative to positive. From negative to what? Positive. So we can say now P is equal to what? It is a vector quantity. So it is a vector quantity, right? So now we understood what is dipole moment properly. P we denote it by P. What is that? Product of either charges and the distance between them is known as dipole moment. P is equal to Q into 2A. Unit is what? Coulomb meter. And then by convention we are taking from negative to positive. By convention we are taking the direction of the dipole is what? From negative to positive. So it is a obviously vector quantity, right? Vector quantity. Fine. Till here, hope so everybody got it. Unit also we learned. Now we'll do numericals related to this. So let's take directly one numerical we'll do here. Suppose one charge is at the center and then one charge is here. This is minus 2q, this is plus 2q. They're asking find, this is A, this is A. Find dipole moment, net dipole moment. So if you'll find here net dipole moment, then directly we can say, okay, see guys, it is 2q charge, right? So 1q charge minus 1q charge you give to this charge, minus 1q charge to give this charge. So we can say between them now the distance is what? A. Between them also there is a distance A. So by convention we are taking the direction is like this, negative to positive. So in this direction dipole moment, in this direction, so net dipole moment is going to be in this direction. Angle is how much? 90 degree. That's it. So first charge is how much? First charge is, let's consider PP only, because anyway direct dipole moment is going to be what? Same. Why? Dipole moment is going to be same. The P into Q, so the dipole moment is going to be what? Same. So P is equal to Q into A. Q into what? A. Yeah, that is going to be the dipole moment. So now we can say P square, again A square plus B square plus 2AB cos theta. P square plus P square plus 2P into P square into what? Cos 90. Cos 90 anyway is 0. So directly we can say root 2P. Root 2P is a net dipole moment. Is what? Net. P net we can say. P net. Okay. Root 2P is what here? Q into A. That is the dipole moment. Hope so you guys got it. That's it about what? Dipole moment. Now we are going to do the universal kind of derivation here. Like if you learn this chapter, everywhere, anywhere in a school, this derivation they will do. So let's do. We'll also have to do this derivation. Electric field due to a dipole at an axial point. Electric field due to a dipole at an axial point. So guys, now if you'll see here, minus q charge plus q charge, and at point P you want to find. Axial means somewhere in the line, right? Somewhere in the line. So we can say at point P we want to find what? Dipole moment. Let's draw it properly. Yeah. So now we can say minus q charge plus q charge. At point P we want to find. Let's take another color. And then we know that this is what? 2A. Distance, the center is what? Let's take from here is what? From here is A. So minus q and plus q, 2a distance is there, and then this point let's consider is what, p, and then this distance let's consider r. Fine. We want to find electric field at point p. If you want to find electric field at point p, we'll have to see individually what is the electric field of this charge, minus q charge at point p. We'll have to see individually what is the electric field due to a charge plus q charge at point p. Then we'll find the net of that, we'll get answer. Fine. So let's see now. You guys understood what I'm trying to do here is, you are supposed to find electric field due to minus q charge at point p, electric field due to plus q charge at point p. That two you will find, you will get answer there. So let's see now. First, electric field, if you will, so electric field is equal to what, guys? Electric field is equal to kq by r square. Electric field is equal to what? Kq by r square. Acha, first let's take kq by r square. So obviously electric field is going to be in this direction. Why this is so? Because negative charge. Now this is positive charge, so electric field is going to be in this direction. Electric field is equal to kq by r square, r plus a whole square. Electric field second, if you will see, kq by what, from here to here, from here to here, the distance is going to be r minus a whole square, r minus a whole square. So we can say now electric field due to one E1 E2 we found. Now guys, we can say easily that what, electric field 2 is greater than electric field 1. Why this is so? Because we can say E1 is greater than E2 because the distance is what, less in E1 E2. See this distance only in E2. So E2 is greater than what, E1, right? So whenever, if you write net electric field, then we can write here E net is equal to E2 minus of E1. That's it. Now we can say KQ by R minus A whole square minus of KQ by R plus A whole square. Correct? Okay. So now KQ will take common. KQ we will take common, and then 1 by R minus A whole square minus of 1 by R plus A whole square, right? So now we can say KQ by R plus A, R minus A whole square, right? So R minus A whole square into R plus A whole square. So now we can say R plus A whole square minus of what, R minus A whole square. That's it, right? So now we can say KQ, if you elaborate it, then R square plus what, A square plus 2AR, right? Minus of R square, I open the bracket, and then minus of what, A square plus of 2AR. Now if you'll see here, R square R square minus A square, can we write like this, R square minus what, A square, 2 whole square, right? A square R square cancel out, right? Now what is remaining here? So we can say directly KQ by what, KQ by 4AR, KQ by 4AR by what, by acha, R is what we are considering is far greater than A. That is the assumption we considered. So A is going to be what, 0. So we can say R to the power what, 4. This R and this R will get cancelled out. So here is what, 3. So now KQ into 2 into 2A, right? That is going to be what, 4, right? And then what, R cube, that is what, E net. Okay. So guys, Q into 2A is what we learned, P, right? Dipole moment. So 2kP by R cube is what, E net. That's it. 2kP by by R cube is what, E net. What I did here is, first we found E1, second we found E2, then we have seen here that E2 is greater than E1. If E2 is greater than E1, then we are supposed to find net electric field. For finding net electric field, what we will have to do here is E1 minus of what, E2 is equal to E net. Then we found what, then this we had done, and we came into this. Fine. So these things, this you write it properly. Then we'll see the next derivation. So next derivation is about electric field due to a dipole at an equatorial point. Equatorial point is what? Suppose this is a dipole, right? You want to find electric field here. You want to find electric field what? Here. Suppose it is a dipole, then you want to find electric field here. So this is a negative charge and this is a positive charge. So we can say E1 will be in this direction, right? And E2 will be what? E2 will be in this direction. So net electric you will have to find. Let's see how it will be that we are going to see now. So we found electric field due to a dipole at an axial point is what? 2 kp by r cube, 2 kp by r cube. That is what net electric field we got. Now we are going to see electric field due to a dipole at an axial point. Electric field due to dipole at an axial point. Yes, so that we are supposed to find now. Let's see how we'll find electric field due to a dipole at an axial point. Minus q charge and what? Plus q charge. So now we can say here q charge here, and guys now see this is what? Minus q charge, and that is what? Plus q charge. So we can say electric field will be what? Towards electric field lines originate from positive charge and terminate on what? Negative charge. So we can say electric field direction will be in this direction, right? For this. Okay. Now see this is a positive charge, this is also a positive charge, so repulsion we want to find somewhere here. So the electric field will be what? Here. We didn't wrote that this point is 2a. Let's take this this is the line, middle line from here. That we assume that this distance is what? R. If you are writing for board, then you should write these things. As we know, this is a negative charge and the top point point P charge is what? Positive. So we can say electric field lines will be towards minus q because originate from, so this point you should write, and then we assume that what? The perpendicular distance is what? R. Fine. And then this distance is what? A. This distance is also A. Now we can say this is R, this is A. So by Pythagoras theorem, what we can say? This will be R square plus what? A square. This is also going to be what? R square plus what? A square. R square plus A square. R square plus A square. Now what we can do here is, now we can do net electric field. Net electric field, see easily. Now we can say, no, this is, let's consider E1, right? This is what? E2. So net electric field is going to be in this direction, right? Let's change the color. So now we can say in this direction. Net electric field is going to be this direction. Now guys, this is theta, so this will also be theta. This is theta, so this will also be what? Theta. Okay. Thetas are same because angles are same here in the triangle. Now we can say E1, right? Here is E1. So we can say E1 when now because electric field is acting at an angle of theta, then we are supposed to do what? Component of that. So we can say E1 cos theta, E2 sin theta. By that way we will have to do. So we can say now here in this direction is what? Whenever theta is attached with the axis, that axis is going to be what? Cos theta. Whenever theta is attached with the axis, that axis is going to be what? Cos theta. So we can say E1 cos theta, E1 cos theta, and this is going to be what? E1 sin theta, E1 sin theta. Now this theta is also attached with this axis, so this axis is also going to be what? E2 cos theta, E2 cos theta, and this component is going to be what? E2 sin theta. See what I did here is, whenever theta is attached with any axis, that axis is going to be what? Cos theta. Apart from that is what? Sin theta. So that is what we did here. Fine. Now we can, guys, let's see one thing we can say here. E1 cos theta and E2 sin theta is going to be what? 0. Why? Because it is, okay, let's see. We will see first, then we will say. Anyway, thetas are same, that we consider already. Let's find E1. E1 is, if you will find, guys, then this is the distance, and then what? Charge is what? Minus q. Anyway, we are not going to consider because electric field is direction is given. So E is equal to kq by r square. R square is what here? R square plus what? A square root under of that. That is what? E1. E2, if you guys will see, then kq by r square plus what? A square root under of that whole square, right? That is what we did, E1 and E2. Okay, now you want to find what? Net electric field. E net, if you will find, then what is going to happen? Okay, first before finding E net, what we are supposed to do here is so we came in a conclusion that what? Yes, E1 and E2 is same, right? If E1 and E2 is same, guys, then we can say that E1 sine theta, angles are same, magnitude is same, so we can say E1 and E1 sine theta and E2 sine theta, the components in vertical direction will cancel each other because in magnitude wise, because in magnitude both are same. Both are what? Same. So we can say that we are not going to consider. Now net electric field is going to be what? In cos theta side. So net electric field is what? E1 cos theta plus what? E2 cos theta. Acha, anyway, E1 is equal to E2 is equal to what? E. So we can say directly 2E cos theta is equal to what? E net. Fine. So once you understood this, then it is easy, no? E net is equal to 2E. E is what here? KQ by R square. R square is what we learned? R square plus A square to the whole square into cos theta. Guys, cos theta is this. So base by hypotenuse. So A by R, right? R is what here? A by R. R is R square plus what? A square. This, right? So now we can say, see, A base by hypotenuse, right? So now we can say 2QA. Q into 2A is what? P, right? Okay, let's write first Q into 2A. And then if you'll see, this and this will get cancelled out. Here power is 1, here power is half, right? If you'll remove it, then root under, then it will become what? Half. And here power is what? 1, because it cancels out root under and square, right? So can we write directly like this? R square plus A square to the power 3 by 2. Yes, right? Again, the assumption is R is far greater than A. So A is going to be what? 0. Acha, Q into 2A is what? P. So KP by what? R is far greater than 0. So R to the power 2. So this will get cancelled out. Then KP by R cube. So electric field at an axial point is what? KP by R cube. KP by R cube. Now guys, 3 formulas we learned in this topic. First we learned about a dipole moment formula. Dipole moment formula is what? See, we learned 3 formulas in this topic. One is what? Dipole moment. Dipole moment is P is equal to Q into 2A. Second thing we learned in this topic is what? About electric field at an axial point. Axial point, if you will see, we did what? 2 kp by r cube, and then equatorial point is what? Kp by r cube. So let's see this all. If you will see, once I'll show you guys like whatever we did in today's class, then we'll do few numericals related to this. So electric field dipole moment we had done here, and then electric field due to a dipole at an axial point we had done. So we got answer 2 kp by r cube, and then we started how we did component, that is important, right? So that we did. After that we got this kp by r cube. Hope so everybody got it. Yeah, so till here, if anybody is having any doubt anywhere, they can comment us, and then we'll obviously will give you a reply. So till here we'll see, and the numericals we'll see in the next part.